Today's video is about part 2, chapter 3, metals and non-metals. So physical properties of metals. So metals generally in daily life we are come across. We are using many utensils, many items made out of metals. So we'll see the properties of metals. Metals have luster, that is, they have a shiny surface. Metals are generally hard. Metals are good conductors of heat and electricity. Metals have high density. Metals have high melting point and boiling point. Metals are malleable and ductile. Metals are sonorous. Sonorous, that is when you hit. When metals are hit hard, they produce sound. All metals are hard and solid except mercury and gallium. They are liquid metals. So your objective type question will be here. Then sodium and potassium, they are two soft metals which can be cut with a knife. Metals are malleable and ductile. So what is malleable? Malleability, the property which metals can be beaten into thin sheets, you called as malleability. Ductility, the property by which metals can be beaten or drawn into thin wires, you called as ductility. Metals that are best conductor of heat and electricity. Silver. Properties of non-metals, we'll go for non-metals. Properties of non-metals. They exist as solids, liquids and gases. So bromine is only liquid non-metal. Non-metals are generally non-lustrous. You don't find any shiny surface except iodine. They have low density and low melting point and low boiling point. They are poor conductors of heat and electricity except graphite. They are not sonorous. So when you hit hard, no sound is produced. They are neither malleable nor ductile. They are soft and brittle, so easily breakable. Strength is very low. This is an activity series. First one is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver and gold. So in the beginning it is on top it is more reactive. As it comes down, the last silver and gold, they are least reactive. So from top to bottom the reactivity decreases. So what is reactivity series? A list of metals arranged in the order of the decreasing reactivity is called as reactivity series. Next we'll go just see how what happens when metals react with oxygen. So when metals react with oxygen, you get the corresponding metal oxide. When aluminium burns in air, so taking aluminium and heat it brightly, and when it burns, you get aluminium oxide, Al2O3. Similarly, when copper is heated, so copper powder, when it is heated with the presence of oxygen and heated, so copper combines to form a black oxide that is known as copper oxide. So this question was also asked. Magnesium burns in oxygen. Magnesium, remember, burns in oxygen. So on heating magnesium ribbon in a flame, it burns brilliantly to form magnesium oxide. So the ash is formed. What happens when metal reacts with water? So you get metallic oxide. The metal oxide plus hydrogen gases evolved. Sodium, potassium, calcium, they all react with water. So sodium and potassium, they react vigorously to produce the corresponding hydroxide and hydrogen gases given out. So for potassium hydroxide, for sodium it is sodium hydroxide, and for calcium it is calcium hydroxide with the evolution of hydrogen. Whereas aluminium and iron react with water, means they do not react with cold water or hot water, they react with steam. So they react with steam to give aluminium oxide and iron oxide with the evolution of hydrogen gas. This is an experiment to show that metals are good conductors of heat. So this is a stand. So this is a stand, and this a clamp, a metal rod or a wire is being taken and is being continuously heated with the help of a lamp or a burner. Then on heating, you can see that the heat it will be hot, very hot here. Slowly the heat passes from this until after few minutes you can find that this part also becomes very hot. This shows metals are good conductors of heat. This is an experiment to show metals are good conductors of electricity. Take 2. This is a small circuit. So in this, to the battery, A and B, 2 wires and clips are being connected. So one wire to this bulb is connected and it is here. The clip is here, to the another wire is taken, and any metal to be tested whether they are good conductors of electricity, you have to be fix it here. On when you switch on, the bulb glows. If the bulb glows, it's a good conductor. Next one is chemical properties of metals. Metals are electron donors and hence they are electropositive. Metals form ionic bonds. Generally, metal displaces hydrogen from dilute acid. Aqueous solution of metallic oxides turn red litmus blue. This means oxides of metals are basic in nature. Some oxides of metal in aqueous solution react with zinc to produce hydrogen. Chemical properties of nonmetals. Nonmetals are electron acceptors and hence they are electronegatives. Generally form both ionic and covalent bond. Nonmetals do not displace hydrogen from dilute acids. Aqueous solution of nonmetallic oxides are turned blue litmus red. This means the oxides of nonmetals are acidic in nature. Aqueous solution of oxides of nonmetal react with carbonates to produce carbon dioxide. So the metal is taken here, the metal sample, iron or aluminium or any metal, and a glass wool soaked in water. So on heating, steam is evolved. So it reacts with the metal, and here hydrogen gas is being collected, bubbles out through this, and it's get collected in the upper portion of the test tube. So inverted test tube here. So this diagram is being asked for 3 marks question. This is an electrolytic refining process. Here in a big tank, electrolytic refining of copper, big tank is taken. Inside 2 electrodes are there, cathode and anode. Pure copper is thin strip of pure copper is taken as a cathode, and this blue color solution is nothing but copper sulfate solution. Just on passing current, so this copper sulfate solution, copper in this solution starts to deposit on this cathode. So pure copper is obtained on the cathode and the impurities settle down as anode, mud. This is an experimental setup to show that for rusting, air and water, moisture, that is air and moisture is needed for rusting. So test tube A is taken, B, C, 3 test tubes are taken, and the setup here is 2 iron nails are kept inside. So in test tube A, air is there and water. Inside this water, iron nail is being dipped inside. 2 nails are being put. In B, air is there, water is there. This water is distilled water, distilled boiled water to remove all the dissolved air in it. And here a layer of oil is being put. So there is no contact of air here for this air and water. There is no contact here. So that is this oil layer prevents that. And the next one is air totally is dry because anhydrous calcium chloride. It's a drying agent. So it absorbs moisture. So in that iron nail is kept. After few days when we observe that rusting process is, we can observe only in test tube A because due to the presence of air and moisture. Whereas here there is no rusting and here also there is no rusting.